Yes, we have a question to solve today. 9 raised by the power of x plus another 9 raised by the power of x equals 54. And we have a set of options, that is 3 over 2, 3 over 4, 6, and 9. And the value of x is going to be what? I know what a lot of people might think is writing this 9 raised by the power of x, then add the power of the second one exactly like this. 9 raised by the power of x plus x equals 54, which is the same thing as 9 raised by the power of 2x equals to 54. Whosoever that do this way is based on the certain rule of indices that says a raised by the power of n times a raised by the power of m then equals to a raised by the power of m plus m. If you ever think you've done something reasonable with this and exactly with this, I am saying this is wrong. And this is because we cannot apply this rule here for a certain reason. You can see that we have multiplication sign in between each expression here, but from the question we have additional sign. You can see that we have additional sign there, which shows that we cannot apply this rule here. We can just apply it. It's not going to work here. So the right approach to this question now is to start with this left hand side by adding them together exactly the way it is. That is, if you have y plus y, definitely it's going to be 2y. So that is exactly what we're going to do here. 9 raised by the power of x plus another 9 raised by the power of x definitely is going to be 2 into 9 raised by the power of x. That is 2 of that, which is definitely equal to 54. So what am I going to do next is to divide both sides by 2, because I can see 2 can go at both sides, meaning this 2 is going to cancel this 2, then 2 here, that's going to be 1, and 2 here, that's going to be 27. At the end of the day, I'm having 9 to the power of x equals to 27. Therefore, in order to find the value of this x, this can be done in 3 ways. You can choose whichever way that you prefer. So we can have method 1, method 2, method 3, whichever way we just have or need to get the value of x accurately. And just before we go into that, can you like the video, share with somebody outside there that is in need of this, make a comment. I'm going to read your comment, then subscribe so that whenever I post another video you're going to have access to that. So to get the value of x, we're going to use the first method here, which is applying natural log to both sides. That is, we're going to apply natural log here. Having done this, we're going to apply this here, that is log a raised by the power of n is just the same thing as n log of a. So to the left hand side here, we're going to have x log of 9 equals to log 27. Then the value of x is going to be log of 27 over log of 9. What we did exactly is that we are interested in x, we are not interested in log 9, so we have to eliminate log 9 here. So what are we going to do? We divide both sides by log 9. If we divide both sides by log 9, definitely this is what we're going to have, because log 9 is going to cancel log 9 here. So we're going to have log 27 over log 9, and that is the value of x. So from here we can split the value of this 27 according to the log of logarithm here. Everyone knows that 27 is just the same thing as 9 times 3. So the value of x now becomes x equals to log 9 times 3 all in brackets, then everything all over log of 9. Having done this, and the next thing we're going to do to this numerator here is to remember that log a times b is just the same thing as log a plus log of b. And if we apply this to this numerator here, we're going to have x equal to log of 9 plus log of 3 the whole stuff all over log of 9. You remember in basic mathematics, this log 9 affect this log 9 up here, and the same log 9 also affect this log 3 up here. That is log 9 over log 9 plus log 3 over log 9. Remember, when we add this together, exactly this is what we're going to get up here. So when we split this, then we get what is at this lower base. And you can see that log 9 is going to go in log 9 just one time. That is here, that is 1, then here, that is 1 over 1, that is just the same thing as 1. Now this is going to become 1 plus log of 3 over log of 9. Having this, remember that 9 can be written by the power of 2, that is 3 raised by the power of 2. That is an index form of 9. So we're gonna have 1 plus, that is log of 3, and all over log of 3 raised by the power of 2. So if we apply this basic fundamental rule here to this log 3 raised by the power of 2, that is this, we apply the same thing here. It means this 2, the power of 2, is going to come here. By then we're going to have 1 plus log 3 over 2 log 3. And if we carry out some division here, log 3 goes there, that's going to be 1, log 3 goes there, that's going to be another 1. So we have 1 over 2 here, then the 1 still remaining here, which is 1 plus 1 over 2, which is same thing as 1 over 2, that is 1.5, and which will be written as 3 over 2. That is the value of my x there. X equals to 3 over 2 is my final answer. And don't forget, we've just used method 1 to get the value of x from this 9 raised by the power of x equals to 27. So we're going to see method 2. Therefore, in this method 2, we're going to apply natural log to both sides as we did earlier on, and we're going to have x log of 9 equals to log of 27. And the next thing we're going to do is x is just going to be equal to log of 27 over log of 9. So what we're going to do now is to rewrite this 27 in an index form, which is going to be 3 raised by the power of 3, and at the same time we're going to apply the same thing to this 9. We're going to write it in an index form that's going to be 3 raised by the power of 2. Unlike the first method, in the first method we actually split 27 into 9 and 3. But here we're not going to do that. We're going to write both 27 and 9 in an index form, that is log of 3 raised by the power of 3, everything over log of 3 raised by the power of 2. And having this, we are bringing the power of 3 to the front here, and at the same time the power of 2 also at the same time. According to this rule, log of a raised by the power of n equals n log of a. Doing this carefully, we're going to have 3 log of 3 over 2 log of 2, 2 log of 3, and that is the value of x. As we can see here, log of 3 is common, and log of 3 is also at the level of the numerator. So log of 3 is going to go here, that's going to be 1 time, then log of 3 is going to go here, that's another 1 time. At the end of the day, what do I have left? That's going to be x equals to 3 over 2. You remember, that is exactly what we got at the first method there, which is this 3 over 2 with the first method. And the second method is a bit shorter than method 1. In order to get the value of x in this method 3, you don't need to apply a natural log to both sides as we did in method 2 here, and at the same time in method 1 here. We are not going to need that in this method 3. We just apply an index rule directly the way it is. And what are we going to do is this 9 is going to be written index form, and at the same time 27 is going to be written in an index form. And if we carefully do that, so 9 is just the same thing as 3 raised by the power of 2, that is just 9, but in an index form. This x is still remaining there, hasn't gone anywhere. And at the same time 27 is going to be 3 raised by the power of 3, because 3 raised by the power of 3 is same thing as 27, and 3 raised by the power of 2 is same thing as 9. To this left hand side, we're going to apply a second rule here, which says whenever we have a raised by the power of m in our parentheses like this, and then we have another power outside there, then we're going to multiply both power together, and this is going to be a raised by the power of n times m. And the same things we're going to apply here. If carefully apply that, we're going to have 3 raised by the power of 2x, because 2 times x is going to be 2x. Then we still have 3 raised by the power of 3 as usual. Having this, is somebody suggesting another rule here? Yes, exactly, which says when we have a raised by the power of n, then equal to the same base, which is a raised by the power of m. This rule says this a is going to go for this a, because don't forget they are just the same thing, that is the same number. Then n is going to be equal to m, and having the same base here, which is 3, and we have the same base here, which is 3, so 3 is going to go for 3, then 2x is going to be equal to 3, that is 2x equals 3. Then at the end of the day, our x is now equals to 3 over 2. That is the final answer there. X is just equal to 3 over 2. Now the third method is the shortest, exactly, and the second method also is shorter. first method is also there. You can make a comment whichever one or whichever way that you prefer. If it is first way, that is first method, it is, yeah, let me know in the comment section. I mean that you prefer. And if it is second method that you prefer, let me see also that in the comment section. And if you choose method 3, well, let me also know in the comment section. And don't forget where we actually started from. 9 raised by the power of x plus 9 raised by the power of x equals to 54. And in all this method, we have gotten x equals to 3 over 2, which shows that the option A is the correct answer here. And to check the value of x, if it is actually what we said it is, that is 3 over 2, we really want to check if this left hand side is just going to be equal to this right hand side. Then if actually it is, then it is verified. So what we're going to do is just to insert 3 over 2, which is the value of x, wherever we find x here. So we have 9 raised by the power of 3 over 2 plus another 9 raised by the power of 3 over 2. We want to check if this is going to be equal to 54 or not. Writing this in an index form, that is 3 raised by the power of 2 and still raised by the power of 3 over 2 plus another 3 raised by the power of 2, then raised by the power of 3 over 2. Is it going to be equal to 54? Let's check. Then if we multiply the power inside the parentheses and the outside, actually this is going to cancel this and this is going to cancel this. Then at the end of the day, what are we going to have is going to be 3 raised by the power of 3 plus another 3 raised by the power of 3, and is this 54 or not? 3 raised by the power of 3, that is 27, and plus another 27, and is it going to be equal to 54? Actually yes, and 27 plus another 27, that's 54, and 54 equals 54. Keep on loving mathematics. And just before we go, kindly like the video, make a comment. I'm gonna read your comment, share, subscribe. I'm gonna really appreciate that because it's gonna help my channel grow. Thank you so much.